Hi, everyone. Thank you for joining today's session of the developer event series. Today, I will cover, I would say, a very important topic, which is domain model design for Cumulocity IoT. And I will try to share some best practices around the design of good domain models of my experience in the past. Let's have some housekeeping rules. I haven't muted all of you yet because I want to keep it in some points of the presentation interactive. So I will ask some questions and you can unmute yourself and maybe give an answer to that, or you use chat to answer in the chat. Also, of course, we will have a Q&A in the end of the session, as always. I already started the recording of the session, and later on, I will upload the recording to our YouTube channel in the IoT Developer Event Series playlist, so you would not miss anything. About today, what I want to show you today, we have some agenda points we have to cover. First of all, I would start with why domain model design for Cumulocity IoT is important at all. Why should I do that, or why should you do that? What is the Cumulocity IoT domain model? What is actually defined as a domain model for Cumulocity IoT? As a third point, I will cover how to design a good domain model based off my experience and experience of some other colleagues. Then I will share some best practices for storing application data, like microservices, or storing also additional data for web UIs or any other kind of data which is not on the context of devices. And then, as the last point, how the domain model design has also some impact of the query language and how to retrieve data out of the platform, and how you can cleverly use it to retrieve the data out of it. And in the end, I will give some summary, what are the key takeaways you should take away, and of course, a Q&A. So let's get started. Why domain model design is important in IoT? When you start with IoT in an IoT project, the first question which comes very often to your mind is how and where I should ingest data, not only to Cumulocity IoT, but in general to an IoT platform. But from our focus, we're talking about Cumulocity IoT. So this is the first question, how and where I should ingest it. What are the protocols? What are the interfaces of the device I can use? And what is the target area? What is the database, how I can store it? Is there any interface of Cumulocity IoT? What kind of interfaces are available? Then the second question, once you have answered that, you have explored the documentation and you know how to integrate your devices maybe, then you ask yourself the question, what is an efficient way to store the data in Cumulocity IoT? Yeah, of course, now I understand how I can send data to Cumulocity, but what is an efficient way to store the data from multiple perspectives, yeah, from query perspective, but also from the perspective of ingesting the data and not sending too much data over the line, for example, all the data which might not be required, all this kind of questions. Then also, of course, related to the second question is, how should I name my data in the fragments, we call it in the domain model. I will later cover that. How should I name my data ideally for Cumulocity IoT? And also, what is an efficient way, once I have stored the data, retrieve and visualize the data? And all this kind of questions comes to your mind when you're starting your project. And the main answer to that is you need a domain model. And Cumulocity has a domain model and enforces somehow you to use this domain model to store your data and answer all this kind of questions. But, and now comes the big but, Cumulocity does not enforce you to do this. Yeah? Cumulocity has a very flexible domain model, and it's not enforced that you, before you ingesting data, model your domain model in a good way and ingesting the data in an efficient way. So it's actually a thing that you should do, but it's not enforced by the Cumulocity IoT platform for flexibility reasons. And also, this is also maybe a little bit different to other platforms in Cumulocity IoT. The model itself is not modeled within any model editor in the platform. It is mainly implemented in the agents running on the devices or gateways or in the microservices which are used to integrate the data to the platform. So in the implementation menu, you also implement your domain model. What are the benefits of having a good domain model? First of all, when you design a domain model in a good way, it enables you to be flexible in the end. With flexibility, I mean here, you can add other devices, you can add other device types, you can add third-party applications more easier than just thinking about the same stuff all again. Yeah, what is a good data bucket for these kinds of data? Do I have already a naming pattern for my devices, like a prefix or something? So flexibility, you can still integrate any kind of device you want to, but it also accelerates you a little bit in that way. It also helps you to scale because, sorry, can you mute yourself? Scaling. If you start with one type of devices, or maybe with a small application, and then you want to roll out another application where other devices are involved and need to be integrated. Once you have a good domain model for your whole solution, it makes it very easy for you because, again, you know which data buckets and which domain model areas you need to store the data and what are the naming patterns and all this kind of stuff. So this enables you to scale out in the end. It accelerates your development speed. The questions if you need to integrate new devices, if you need to develop new user interfaces, the developers don't have to ask the question, okay, now, but how are the fragments named in this case? Because this question is already answered by a good domain model because you have some naming patterns. You know that the fragments should have a prefix, for example, and the naming should be like this, that the data should be mainly in events or in managed objects. So the developer does not have to ask this question anymore. It is clear, you just have a domain model. And once you scale out your solution, it accelerates also to develop new components for this solution. It also enables you or increases the efficiency of your data retrieval because you know and you have defined somehow standards in your domain model. You also know how to retrieve them efficiently, like having very efficient queries to get a lot of data, which is basically mainly needed for a part of the solution. And in the end, it avoids that you have double efforts and costs, which is somehow also related to development, scaling, and flexibility. That if you have done something like a model designed already, integrated a device, and then you have another device, you don't start from scratch designing a data model for this device, designing an UI for this device only. You just do this in general for the solution, and you don't have that anymore. And also very important, you don't need to adapt them because your data model hopefully stays stable. And this reduces the cost in the edge of a project because you don't have to start it again and have, again, efforts in that area. So this is the main motivation. But from my experience and the experience of some colleagues in the past, in the project we were part of, we see a lot of things that went wrong. Okay. Can you please mute yourself? Maybe I should just. So what could possibly go wrong without a data model? Yeah. So first of all, what I saw that I see a lot also currently that you have a device which is sending some data, and the data is not harmonized in anything. It's just forwarded like it is to the managed object, to the events, like, for example, having a plain JSON or having a plain XML or even any other kind of data format. And it's not mapped to the structure of the Cumulocity domain model. It's just forwarded as is and just stored in the database of Cumulocity. Yeah, so this is a common pitfall because you cannot efficiently use this kind of data in the platform. The other way around is that I also saw projects where a lot of time was invested to have a perfect data model in the end, very sophisticated data model for the solution. But in the end, it was not fitting to the real device data and the real application data. So the idea was to have a very good data model in the end, but the devices delivered different data or not the data which were modeled in the data model, which is also not matching and which somehow makes it very hard then to map this kind of data in this data model and to use this data model. So it's kind of over-engineering. This is also happening, both of these cases, because in the IoT, we have some standards of data models, but not for every cases. Very good example here is, for example, MQTT, which is just a protocol to integrate, to communicate, but it does not have any specification about the data model, which is sent by MQTT. So you can just basically send everything over MQTT and there's no standard. Another good example here is Lightweight M2M, where the data model is part of the specification partially and also defines the data model. But in most of the projects I attended, there were no standards of data models, so you have to come up with your own data model. And this leads to the issues I mentioned above. Also, because there was no data model, I saw that a lot of adaptation needs to be done in the project. So you started, you integrated the device, and then a new device has been added or the device has been changed because the firmware has been deployed with a new interface or new data coming in. Then we needed to adapt the APIs of the platform a little bit. And also because the APIs has been changed, we need to adapt the web interfaces all the time. So, and if you then have some other applications connecting to the APIs, maybe you have also to adapt the external applications. And this one you want to avoid, but we see also this a lot in the past. Also what we saw, you ingested the data, but you did not have in mind how to retrieve the data out of the platform. So you just forwarded the data, but then retrieving the data was very inefficiently. So it takes a couple of seconds, even minutes, even hours to retrieve the data out of the platform with really bad performance because the data was not optimized to retrieve in an efficient way. So that's also what we see. Sometimes also we see that objects has been created in the platform and they should be correlated, but there was a missing correlation IDs between the platform. Also the hierarchies which are supported by the platform were not used. But in the end, the solution came up and say, okay, now this object is related in this way, but for the application, you need to correlate them, but there are no IDs stored in the platform. How can we now add new correlation IDs so we can actually correlate the objects? And because of all these issues, we saw also that projects escalating, platform is not behaving very well. We had a lot of performance issues, which is also involving a lot of high costs, of course, costs for having new hardware provided, maybe cost of doing some research, what is the root cause of that, and a lot of effort. This is actually stopping your project to be proceeding, and it's not very nice. Also, if you just store any data coming into the platform, it will have a lot impact, very high impact of the storage cost. So some projects start in the very beginning and saying, I just want to store everything which is coming in from the platform. If you're aware of the Cumulocity pricing model and Cumulocity data structure, this is not a good way to do that. You should do some pre-filtering. But at the beginning, some projects started, I will just store everything and I will take care later on the filtering and what data is relevant for me. And I can just continue a lot of other things which happened mainly because there was no good domain model designed at the beginning of the project phase. And this is why I really urge you, before you start an IoT project in general, but also with Cumulocity IoT, you should have a good domain model, a good data model in mind and define it for your solution. One solution or partially solution of this is the Cumulocity domain model, but the domain model of Cumulocity IoT will not give you all the answers which you need. So this is why I also had prepared some best practices, but start with a domain model. Cumulocity IoT domain model has in center, we call it inventory. In the inventory, you store so-called managed objects, which can be mainly, of course, devices, assets, configuration, metadata, groups. So anything which is more like some data which should persist in the platform. So no transactional data. This is the inventory. This is the center of the whole domain model. If you do not have any object in the inventory, most likely you cannot store any other of the buckets here. So you always need one object in the inventory, and on that object of the inventory, you can store additional data. For example, I have created a device in the inventory, then I can create multiple measurements, operation events, alarms, and audit logs for that device. Same for assets and same for other objects. So this is mainly the inventory. For the inventory, we have the measurements. Measurements are time series data. These are transactional and historical data, which is mainly numeric values over the time. Then we have events, which is non-numeric values, can also be because of course, numeric, but unstructured or very complex data. Again, this is also transactional data and historical data. Then we have the alarms, which are kind of similar to the events, but with more specific focus, because alarms are mainly used to indicate in the platform that there is something wrong and you should have attention on some object. Again, this is also transactional and historical data. Then we have the operation. The operation is the data created in the platform, but should be sent to the devices. We call this downlink messages. Again, also operations are transactional and historical. And then we have finally the audit logs, which are persisted also in the platform to persist changes on objects which might have changed. For example, if an inventory has been changed, a user has been created, or a user has been changed, you persist such things in the audit logs. Again, this is also transactional and historical. So this is the domain model. But this domain model is very flexible. And again, Cumulocity IoT does not enforce you to define a domain model, and it forces you to use the structure somehow, but it does not enforce you how you store the data in an inventory in an event. So this is why I want to give you some guidance how a good domain model on top of this Cumulocity domain model can look like. Let's get started with the differentiations, we call it MEARs, measurement events alarms. These are transactional data. Again, measurement event alarm always needs to have a device or an inventory managed object as a center. They are used if you want to have historical view of over a certain time. From an operation perspective, you mainly post them. So just create new measurements, events, alarm, you only partially update them. For example, if you have a temperature value on a timestamp, you just create it, but you will not update the measurement most lately. For events, it's kind of different. Of course, you will create a lot of events, but mainly you can also update an event with some updates if there's a status that needs to be updated. But again, the main operation on mirrors are create operations. Because you create a lot of these kind of documents, your database will grow very rapidly in this regard. And for that, the Cumulocity IoT platform has a solution in place, which we call retention rules. And all the mirrors, so transactional data actually, can be defined that should be deleted from the platform under defined conditions. For example, all measurements of type X should be deleted after 14 days. And you can define this also for events and alarms and so on. Yeah, because it's not so important to keep track of a specific type of measurement, which is common per second. But if you have an important event coming just one per day, you mainly keep it for 30 days or even longer. So these are the retention rules, which help you to keep track of and keep a view on your storage in the Cumulocity IoT platform. On the other side, we have the inventory, where we can store managed object, which is metadata, which is persisting. So no retention rules for that. They do not apply for deleting devices, assets, or whatever. If you want to delete a device, you have to do this manually via the user interface or using the API. Per default, an inventory or a managed object does not have a timestamp. So it does not enforce that you have to store anything and related to a timestamp, but of course you can store timestamps in your managed object. The main focus or main goal of a managed object is to persist a current state. So if you have device object and you have the device, then this device object should be a digital twin of your device with all the states coming from that device. Is the device online, offline? What kind of firmware is represented on that device? What kind of software is on that kind of device? Which hardware revision is this device on? This is all persisted in the managed object and all other data you can think of. The main operation for an inventory object is mainly a put and update operation. Only at the beginning, if you register a device, you will create the managed object. And of course, if you saying like this is not relevant for me, then you will delete it. But this is, I would say, at the beginning and in the end, you just one operation. But the main operation to update the state of the device is the put update operation of the inventory. And I already said that no retention rules applied for that. So in summary, the mirrors, measurement events, alarms should be used for historical and transactional data like sensor values, device events, or alarms occurred on your devices. The inventory with managed object should be used for metadata, describing and persisting a current state of an object. And of course, you can combine them. This means you have measurements values, you have events, which contains a state where you have where you want to have this historical view, but you would also maybe update the state of the managed object. So you can actually do that. You just create an event, and this is second operation. You update the inventory object and setting the state to the new value coming from that device. Now let's talk about the managed object design in detail. So first of all, when we talk about managed object, again, we are in the inventory part now. We're talking about metadata. A good thing is that you assign an external ID to that. In Cumulocity IoT, we have a loosely coupled concept for that. All the inventory objects have mainly an internal ID, which is generated when you created them. You can see them on the right here on the ID. This is an example of an internal ID. But Devices and other objects most likely have an external ID, like a MAC address, a serial number, or whatever you can think of, which is the unique IDs. And here we have the identity API, which allows you to create these external IDs and assign them to your inventory object. And this is also a best practice. If you create a managed object in the inventory and you want to retrieve it later on, and you don't want to persist the internal ID, then you should always create an external ID and assign it to the device. And as you can see on the example on the right, it does not only enforce you to have only one external ID, it can have multiple external IDs. In this example, I just used the MAC address, for example, and here, which is not a so good example, is also the serial number, which should be mainly another number, but here I also use the MAC address. But I think the idea is clear. If a device has a serial number and you know that, you can create it under the serial type. If it has also a MAC address and any other unique identifier, you can also create them here and can identify the device by that identifier. This allows you to retrieve the managed object very easily, because you can just, with one query, saying, give me a device with this unique ID, then you have the managed object and you can just have very efficient way to access this managed object and maybe updating it or just retrieving it. If you have a lot of devices in your platform, especially when you use the microservices, which manages all this kind of devices, then it is kind of best practice that you not always go to the identity API and query with the external ID the managed object, because the response is in most cases always the same. The managed object ID will not change much. If this is the case and you always frequently want to retrieve this managed object, caching is a good solution to do that. Yeah, so in this way, you can think about you retrieving an identity, unique ID like the MAC address, and you retrieve the internal ID and you store it locally in your application in a hash map or whatever, and you synchronize that. Yeah. So once again, a new request coming in, requesting for the MAC address, you going to the cache first, checking if there's a cache with the managed object ID. And if it's not the case, then of course you go to the identity API to do that. But first of all, you can use the cache, which is much more efficient to retrieve the object. Also, this identity also allows a very nice way to do a device replacement without data loss. Think about that you have a managed object, which is an asset, where we have some devices assigned and you have an identity assigned to that, and you want to replace this device, but you don't want to lose the data on this managed object. So there are some concepts how you can realize the scenario. One concept is that you just exchange the identity with a new physical device on that managed object, and then you have all the data, the old data and the new data on the same managed object. If you want to do it so. You can also create a new managed object with a new ID, and then you have a new managed object, and then you have the old data on the old managed object, the new data on the new managed object. This can be all realized with the identity API. For MQTT, this is a special case because there you don't work with internal IDs, and for MQTT, the client ID is the ID which is added as an external ID to the managed object automatically. So if you integrate your device with MQTT, you don't have to take care about external ID if you set the client ID right to the ID you want to have. So this is the identity, and you should definitely use that if you want to store your devices in Cumulocity. Another side effect, if you don't use the identity API, and I also see this a lot in the past, I saw this a lot in the past, is you create a managed object, you forget to create an external ID, and then you create another request is coming in, and then you create just a new managed object because there's no external ID with this unique ID, and then you have multiple objects in your platform for the same device. And this one you want to avoid by using an external ID. Now, a question to you. Let's talk about the managed object design. If you have some experience already with in Cumulocity, then I have brought some 2 examples here. On the left is example 1 of a managed object describing a sensor, and on the right I have the same in a different kind of way. What would you think is a better way to store a managed object in the inventory? Example 1 or example 2? And if you say example 1 or example 2, why? How would you say what is better in this example?
I think Anyone? It depends on the use case.
Yeah.
Basically, the bottom line here is that top level fragments are always indexed. So if you want to access your whole all your custom properties at once, maybe the second one is better. And if you want more granular access to your data, then the first one is better.
Okay. Any other opinions? Or same opinion?
I think number 1 is better. I think that one of the problems that I see with number 2, and I think is that the name and the type are very specific. Number 1 is more general, which makes it better. And I think I have had issues in the past with how do you say that, fragments that belong to other fragment, especially when it's being updated, because we have had problems. The how do you say this?
Access this nested structure.
Yes, the access is not. You cannot guarantee that it is done in the way you want it. While if you have single level fragments, you can guarantee that you can update the managed object without having to worry about the order in which it happens.
Yeah. Okay. Third opinion on that?
Yeah, I think another good thing about example 1 is that if you do a put operation on the managed object, in example 2, you have to send the whole object of custom solution properties. And if you just want to update property number 2, in example 1, you would only need to send the custom property 2.
Okay. So basically what you said is true, all of you. Yeah, but there are still some things which I'm missing, and I try to explain it on the next slide. But first of all, let's start here. From the naming perspective, I would say this name versus this name, this is more readable. If we're talking about Cumulocity IoT, this is of course more efficient to store, but this is more readable. And the name of the inventory should in the end be readable somehow. And the name is also used for the user interfaces, like in device management for the cockpit. And if you have a device named like this, it's very hard for the users to recognize what kind of device is this. Yeah, so I would suggest that you have a readable name of your object, which is saying, okay, this is an object like a multi-sensor. This is just something. It could be a container as an asset, could be the device name, how you name, and also including an identifier. If you just have multi-sensor or just the device and missing out an identifier in the name, you have maybe thousands of devices naming the same, which is also possible in Cumulocity because the name is not a key. The name can be the same of all the managed objects, which makes it very hard then to identify the right device very easily. Yeah? So from the naming perspective, this is better here on the example 1. For the type perspective, it's similar. For the type, I would go that we would have some device class we want to identify for devices, or asset class, or any kind of managed object class to identify, okay, there are multiple objects of these types in my database. For example, I have hundreds of LoRa multisensor specifying, okay, this is using maybe the protocol LoRa coming or connected via LoRa, and I know this is the multisensor. And if I want to identify all the kinds of sensors by type, I can easily retrieve them using the type. So having a very good type name with a prefix and a good naming describing the device or the asset is important here. And this contains an identifier. An identifier in the type is not very good because then you only have one type for, you have a one-one relation. You have one type for one device instance. Yeah, and so it does not make sense at all to use the to use the type, and you cannot in the end efficiently retrieve the device classes. Yeah, so this is much better also on the left side. Now comes to the thing about the nested structure. Here you see a main difference that we have one, we call this one a fragment. This is also a fragment. And in that fragment, we have a complex object here with multiple other properties. And here we have an array. This is one thing, or one how you can do this in the platform. And on the left side, we have flat properties. We have property 1, property 2, and we don't have the cast solution properties. Also, on the right side, we have an issue with the dots. Dots should not be used in fragment names. Yeah, I will come to that later on. There are some other things which should not be used in fragment names. You should mainly use underscores. And also, it is a good practice that you have a prefix for the property. That you say, okay, this is a property defining in my solution. Maybe the solution is the prefix. If this is the prefix for some, I would say, metadata or not sensitive data, but any kind of other data describing, then maybe you find a different prefix. So you can actually see on the prefix already what kind of data is persisted in that fragment. Also, what you said is retrieving the data and updating the data is true. Here, if I want to update the customer property, I just have to provide the my property and with a new value. Here, if I want to update only customer property 1, I need to provide all the data in that fragment. Otherwise, if I just update customer property 1, all the data will, all the other fragments and properties will be deleted. So if you have a very complex fragment with a lot of data and you need to frequently update it, you have to send a lot of other data which might not have changed to update these fragments. So here, this is a way better way to updating the data on a frequent way to make it more easier. Also for the data retrieval, it's more efficient to have it like that because here, if you want to filter on some data, you can filter only on this level here easily. You can also filter on other ones, but not so easy. Here, you can just add, I want filter all the devices or all the managed objects which have the customer property 1 fragment. And then you get all the objects with this value, which is much more easier than filtering out in the nested structure. So in overall, the example 1 is the way I would prefer you to implement things. But of course, there are some other things which also make sense to use nested structure, but you should not use dots. Yeah, to summarize that, here, everything I've just said, use a meaningful name and type. The name should, in best case, include a short and meaningful descriptor and an UID. Yeah, like here, the multisensor as an example. The type should not contain any unique IDs, but should describe the device or object class. So we can easily retrieve the objects. The custom fragment should start with a prefix and a meaningful name. For example, for LoRa, you can here, as an example, have LoRa connectivity status. So if the device is connected to the LoRa backend and persisted status in the device. The fragment names must not contain white spaces or any of these special characters like dots, stars, $, and whatever slashes. Yeah, don't use them in fragment names. Most likely, if you want to, you can use camel case or you can use underscores. And in most cases, I would ask you to prefer the flat properties versus the nested properties due to the things I just said. You can easier retrieve them, you can easier update them. There are also some cases, of course, where nested structure makes totally sense, but in the most cases I saw in the past, the flat structure is more efficient to retrieve and update the managed object. Let's talk about the managed object size and hierarchies. The managed object itself can be created, and there's, of course, a limit of size in that managed object. And this maximum size is related to the MongoDB max size, which is 16 megabytes. This does not mean you should use 16 megabytes in the platform. This mainly means you should keep it very lean with all the things you want to store in the managed object, but you should not store any big files, pictures, or any other data there because it has a direct impact of the query performance. Yeah, so keep it as lean as possible, but also with, of course, with all the things you want to describe. Avoid high frequency updates. Of course, you can update your managed object, but you should not do this in second area. You can also, if you implement a microservices, combine the changes of multiple things you retrieve from the device. And if you have done all the changes collected, just do one update on the managed object. Yeah, so not updating it all the time. You can think about also batching that kind of thing. You can use the hierarchies to outsource data. Yeah, if you think, okay, now I have some data which might have relevance to my device, but also is growing very big because it's very extensive describing data, then you can think about using one of these three options to add this to a different object and assign it to the root device. For example, we can have three types of hierarchies. We can have child devices, which are just another device, which is visible in device management and cockpit. We can have child assets, which are not devices, but assets, not visible in device management, but also visible in cockpit. Examples, yeah, groups, containers, buildings, or whatever. And we have child additions. And child additions are mainly the leaf of the hierarchy. And here, you can store any extending additional data. One good example I always bring up is for the device management software management. For once a while, we stored all the data in the managed object of the device itself. In the past releases, we changed that. We're using now child additions to store the software lists in child additions objects. Because we saw that the software list, especially for very complex devices, Linux devices or whatever, is growing very rapidly and it could be very extensive. So, and also services, maybe if you have a lot of services, you can store them in the managed object, but most likely it's a good idea to outsource this in child addition. For the hierarchies, there are two things you have to have in mind. Their permissions are inherited across the tree. So if you have access on this device, on the root device, you also have access on the devices below. Yeah. There's one thing I want also that you be a little bit cautious about is that if you're using the hierarchy, sometimes it is possible that you can do circles. Yeah, very, very easy example here is that you have device A has a child device, device B, and then what you define as device B should be the root device, or device A should be a child device of device B, and then you have a circle, which impacts of really bad behavior on the query, which is an infinite request in that end. That if you will, for example, request device A with all the parent, with all the children, then it will run forever. Yeah, and this one you should avoid. You should have in mind that this should be avoided in your solution. Okay, for time reason, I will skip the demo, but later on, I just wanted to show you how you can use the REST API. Well, we'll not do this today because I have to hurry up a little bit. Let's talk about the measurement design. First, we talked about the inventory. Now we talk about the mirrors. Measurement. For measurements, the structure is very given which is special for Cumulocity, because here we have defined a measurement should always have a time, a source, which is a device or a managed object, a type, one or multiple fragments, this one or multiple series, this in fact exactly one value, numeric value, and an optional unit. On the right, you can see an example. Here I have one timestamp. I have managed object ID assigned. I have a type. I have one fragment here, not multiple fragments, but this two series. And best practice here for the measurement is if you have the same timestamp, for example, a device sending multiple sensor values on the same timestamp, then you can just create one measurement document and not using multiple measurement documents with the same timestamp. And here we can use the concept of having multiple fragments and multiple series. In this example, you can see that same timestamp, I'm used just one fragment with two series. Yeah, so this is for storing the data, it's very efficiently, and for retrieving the data, it's also very efficiently because I just retrieve then one document and not multiple documents. The measurement allows that you can define custom fragments, like we also used or saw on the inventory object, but I would ask you not to do that, because it does not make sense. With custom fragment, I mean not following the structure, like storing any additional data. For some specific use cases, this makes sense, but in most use cases I saw in my past is we should not use them, and because we want efficiently retrieve numeric values, which are measurement documents, and for anything else, we just use events. Yeah, so we just use numeric values, multiple values, measurements. If I have any other data related to it, I should use an event. Events, kind of similar to measurements, but here we don't have to focus on numeric values. Still, we have a timestamp. We have a source, which is a managed object. We have a description, which is a text for the UIs. We have a type of events. And then we are totally flexible. I can have multiple custom fragments. On the right, you can see an example. Here I have the type cast produced path. The text is produced part event, and then it contains the produced part which has been produced. This could be also, of course, an array. It could be a complex object. It really depends on my design and how to use it. But here again, I choose that I put them together, and then I have the name and the part ID. I have an array, and then I have just a plain property that the status of the produced part is okay. So this is a total fine event in the end I can use. Also, of course, the same principle for the inventory managed objects apply. If you can flatten the properties and it makes sense to store them in a flattened thing, then you should use that. If nested is more efficient for your use case, then use it. Here I choose a nested structure because I define the produced part always contains a name and a part ID. And I always want to update and retrieve the whole thing and not only just the name and not only just the ID. So this makes sense for having nested structure. Here for the status, I do not want to put it here in the produced part because I just want to get the overall overview about the event, if the status is okay or not okay. Just an example. Okay. Let's talk about the alarms design. Alarms need a timestamp, a source, again, as a managed object. Here we have also, like similar to the events, a text, we have a type. And this is special for the alarms. We have a severity, which is an enumeration of the following values: critical, major, minor, and warning. Also, you can add multiple custom fragments to the alarms. Similar to the events, if it's not really required to put additional data to the alarms, I would also not asking you to do so, because here now data retrieval is important, because the API does not provide a fragment value filter for the alarm API. For the event API, we have this kind of filter. So if I just go back, I can filter all the events which have a fragment custom produced part. For the alarms, I cannot filter the alarms which have a custom fragment. So if this is an important for your solution and you want to retrieve alarms only with a custom fragment, this is not possible. You should use event instead. Or you can combine them again. Use an alarm, create an alarm, and use an event in addition, and then you can filter the events. For the alarms, there's this very special behavior, which I cannot describe because of time here in detail, but there's a deduplication for the same alarm type. So if I just create a new alarm and then changing the text and just sending the same alarm again with the same type, the text will not be updated. It's just a counter increasing the number that there's another alarm coming up. There are some special things. There's a very nice article in the tech community about that, describing this behavior. You should be aware of this in the alarms. Let's talk about the operation design. The operation design, again, is the data created in the platform and should be mainly sent to the device and then doing something on the device, executing a command, firmware updates, software updates. For the structure, it's very basic. We have an identifier, which is the device ID. This is the internal device ID. This is similar to source on the others. And it should have exactly one fragment containing a meaningful description for, or meaningful content for the device. In this example, I have a fragment called CHY command with a text, and the device knows if I retrieve an operation with that, I should execute what is written in the text thing. If I send in software update, then I have a software, CHY software list here, and then the software list contains everything I need to install, update, or remove. There are a lot of predefined operations already defined in the so-called device management library. The fragment name here is really important because it's also used to map it to specific templates on the Smart REST template in MQTT. So you can, of course, define your own custom fragments in an operation, but then in MQTT, it's not mapped to static default messages. So you need to define your own MQTT messages based on that fragment, but this is, of course, possible. And also, one of the most important thing, don't use multiple fragments, otherwise it's not clear what kind of operation should be then done and how this operation should be updated if I have here multiple fragments, which is confusing the device. Instead, you can use bulk operations where you have multiple operations with multiple different kinds of commands or things that need to be done. Or you can combine multiple tasks for the device in one custom fragment and send it to the device. This is kind of best practice. Okay, let's talk about best practices for application data. With application data, I mean data which is used by microservices. Basically, you have three options to do that. First option, you can use the inventory API. You can store any application data to manage object. You can also use the hierarchy, of course. You can use the identity API. You can store any kind of data there. Second options are the so-called tenant options. In each tenant, you have the feature to store data in a very simple key value store. And third option is so-called tenant object, which is mainly used if you have an enterprise tenant and creating multiple subtenants. You can store from the enterprise tenant additional data to the tenant objects. Here we have this very specific behavior that from the enterprise perspective, you can write data to the tenant object, but the subtenant can only read this kind of data. These are the three options you have to store application data. Option one is you are very flexible. You can use store any kind of data. It does not contain any kind of encryption out of the box. So managed object might not be the ideal way to store any credentials if you're not encrypting them manually. It's also very easy and fast to query it. Here on the right, I just posted an example of a microservice I've developed to store additional information about mappings to MQTT. And when the microservices on UI is opened, I will retrieve the mappings filter the mappings on the fragment type. And on the fragment type, I will then retrieve all the mappings and visualize them in the UI. This is actually things which is a good example to store in the managed object. Let's talk about the tenant options. The tenant options are key value store. You have specific categories. You can simply fast access them data in application. And one benefit of using the tenant option is it has a built-in encryption for sensitive data. If you add the prefix credentials to the key, the value will be encrypted and is only accessible for the service user, which is mainly used in a microservice environment, to actually decrypt it and then use that value. This is very useful if you want to store credentials to third-party services. Then managed object might not be a so good idea, but the tenant options is a very nice idea to put credentials there. Here's also another example for the MQTT mapper I have developed. I stored the credentials to the MQTT broker, which are encrypted here. And I also stored some service configuration, like the logging of the payload, and if I want to enable the logging of the substitution of the mappings, which I can then easily configure in the tenant if I want to enable it or not enable it, which is the key value store then in the end. And then the third option, which is the tenant object, which is kind of an edge case. Here I, again, only the enterprise tenant who is creating the subtenant can write data to it. We have a fragment called custom properties, where you can store any kind of additional data to your tenant. The subtenant can only read this kind of data. A very good example, kind of information which can be stored in a tenant objects are billing relevant information, like statistics, how many devices have licenses in a tenant, or how many devices has been created so far in that tenant. All this kind of information can be created, but only from the enterprise tenant, from the parent tenant. The subtenant can just read it and can just visualize this information. It cannot change these values. Yeah, this is also very important. In most cases, I saw the managed object or the tenant options is used. For some cases, it does make sense to use the tenant object for application data. And now to the last thing of the application data are the audit records. The audit records are used to track changes in the platform. So if something has been changed and the application is changing, has been unsubscribed, the user has changed his username, a new user has been created, you can use the audit log to track them. If you have a custom component, you can also add your record to the audit log. Similar to the MIAs, for the audit records, the data in the audit logs are cleaned up by the retention rules. So you can configure that specific data should be deleted from the audit logs. So, the structure is pretty complex in the end, but it also enables you to store a lot of data. I will not go into detail. You have just small hint. You have the change object, which helps you to see a change from a previous value to a new value with the attribute and the type. And then you can see that the value from when property or attribute has been changed if you want to use it. Here's an example where I changed the first name of the user, and you can see the first name, it was not defined. The previous value was null, and I changed it to another name. And this is an audit record. Again, I'm running out of time, so no demo. For the query language, I will just get roughly through it. To efficiently retrieve the data out of the platform, you have to have in mind that some data is indexed and some data is not indexed in the platform. This really depends on the instance you are using and the tenant you are using. Yeah, but in general, here's an example of some properties of some parameters of the 1017 EU latest, where I defined the per API which parameters are indexed and which are not indexed. And if you want to retrieve data very efficiently, then you should mainly use parameters of an index. If you're not using a parameter of an index, it can have an impact of your query performance, especially if you want to retrieve a lot of devices or other documents like measurements and so on. So have that in mind and always try to involve an indexed query parameter. There's a very simple trick how you can achieve that. I have two examples here. One, I will start with the one below. I have here now a query defined on the managed object, just querying for a custom myFragment, which is test string, which is not using any index because I'm just having a query and filtering a value of a custom fragment. So here I will do a so-called collection scan, which is not very efficient in the end. I can improve my query if I add a parameter where I have an index on. And here I just added the query parameter type and added P8Y DMX example device, which is I know it's a device, and have the custom myFragment also including test string. But here now the query will go to the index, filter on an index based the devices, and later on then filter the filtered list with the test string, which is much more efficient in large data sets. So if you want to improve your queries, add a parameter which has been indexed. So I'm running out of time. We're already 3 minutes over time. So what you should take away. Why domain model design is important. It enables you and avoids that you run into costly pitfalls. It helps you to scale your solution more easier and more faster. It also helps you to be more flexible, of course. For the domain model design, you need to find the right place to store your data, and you need to optimize the way how you should store the data in regards of size, hierarchy, permissions, naming of fragments, and so on. For the application data, the same, find the right place where you want to store the data, like do I want to store the data in the inventory, in the tenant option, or the tenant object. Use audit records if you want to track changes of your application, and optimize your queries using an index parameter. This should be the key takeaways. If you want to have a look in details about this, I have written 3 articles of all these things with a lot of examples in the tech community. First, the main argument is about the first article is about why it's important. The second one, just covering all what is a good domain model design. And the third article is addressing the query performance and application data. And I also added a lot of other links here in the slide, which are related to the things I just saw, like all the OpenAI documentation, and also some other additional documents, which with some best practices like the device vendor require. I know that we are already over time, but I want to open the mics or asking you for any questions. Let's see. Some question in the chat. Okay, the alarm deduplication design I can share in the chat later on. Is it also a good practice to add a description to an open to helps to visualize that? Yeah, okay, this is a comment from Philip. Yes, I missed that. Is there anything in the SDKs to help maintain consistency when writing to multiple parts of the domain model? For example, when writing an event and storing the current state in an inventory, is it up to us to implement it? Yeah, unfortunately, in the SDK, it's not, any of these best practices are not implemented in that way. So you have to do it on your own. Yeah, so if you're writing an event and want to store it in the inventory, you have to implement it on your own. There's no such simple function, do both, and then setting a Boolean to true, and then it will be updated automatically right now. Here's the link. If any has the link, okay, just an old chat. Please also don't save any large data such base in the inventory. Yeah, I think I made this clear. Keep the inventory lean if possible. Yeah, there's a good hint of Henrik. There's also the binary API. If you have, for example, large files which might be stored to the platform, there's a binary API where you can upload your binaries, for example, images, and then reference into the managed object. Are there situations where good practices increase the billable value of C8Y users? I think I would argue yes, there is, because sometimes it also has an impact of the data which is then forwarded to Cumulocity, which also have an impact of what is charged to the customers in the end. Because if you store a lot of data in the database, it has definitely an impact on cost, which also has an impact of price. And if you increase that by having a much more efficient data model in the end, this leads to more efficient, I would say, use cases for the customers to use Cumulocity IT. Yes, and there's a hint by Philip Emmel how you can do this. And I would actually would love that and send it around later on. There's a query parameter, explain query. And in this, you can find out if your query is using an index or using collection scan to actually retrieve the data. Any other questions? Andre, you raised the hand.
That's okay. I mean, you answered the question. I will send you a private message.
Perfect. Last chance for any other question. Okay. Here. Thank you very much for attending. I know this was a lot of stuff, yeah, but I think it's a very important topic. Again, I would ask you to read the articles, give me feedback with additional things like Philip just created, okay, operation, the description might also be important. I will update the articles accordingly and I will share it with you later on. Also, the recording, of course, is uploaded to YouTube. And you can also get the presentation with all the links so you can explore them yourself. Thanks again for attending. See you one of the next events. Bye, guys.